So whatever I discussed today is very, very important, especially when you want to write your folio later on. The meaning of all this, okay? So please, okay, so now when we look at the problem, opening problem, I have one question for you. Okay, can you tell me why I must write down the value for the variable or price value 0? Can someone answer me? Can someone answer me?
Wait, sorry, can you repeat the question?
Why there is a variable, the price value, correct? Why there is a 0 there? Because the question said winning a prize worth 2, 5, 10, 20.
Because the probability of winning a prize worth 0 is 0.5.
How you know it's 0.5?
It states in the table.
The table, if I don't give you the table, just based on the statement there, why the table must put this one? The price is only 2, 5, 10, and 20 what? If I don't give you the table, I ask you to produce a table, then can you produce? Because so I'm asking you, why on the table here? Under the price value, why must there be a 0 here? What does the 0 here means to you? Yeah, because this is getting nothing. So you include all the possible outcome. So they only give you in the question, they only give you 1, 2, 3, 4 outcomes. That is 2, 5, 10, and 20. Correct? So there is another possible outcome they didn't mention to you. That is you get nothing. That is also one of the price value. And the probability for this one add up, the question say is 50%. So the probability here, so usually we let the price be X and the probability for X to happen. Okay, when you talk about probability, you always put in decimal. So you see all this add up is 50%. So you have a 50% chance of not getting anything. So this is something that you have to fill in by yourself if the question didn't give you. The question will give you probability of getting 2 is how much, 3, 5 is how much, 10 is how much, 20 is how much. So you yourself have to put in the price 0. Okay, so these are why the probability must be equal to 1, because you are talking about all the possible outcome for that variable. So our random variable here is price value. Our random variable is the price value that you get. Okay, now my first question, what is a random variable? Can anyone answer me? What is a random variable? Anyone want to try? If, for example, I toss a coin, I got the possible outcome is head or tail. Do you call head or tail a random variable? Kevin have given me that a random variable is you use number to describe. So how are you going to put it properly? What do you mean by a random variable? You know variable in maths, it must be number. So head or tail, do you call it a random variable? Definitely no. So how are you going to put, what if the question asks, what is a random variable? If you're writing your folio, you want to define a random variable. So how are you going to define? Using numerical value to describe the result. Okay, so when you talk about probability, when you talk about an event, we don't use the word result, we use the word outcomes. So what is a random variable?
The possible outcomes.
It's just a possible outcome. When I toss a coin, I got head or tail. That is also a possible outcome. So who can tell me what is a random variable? Put it. So this is called a random variable. A random variable takes on the possible numerical outcomes of a chance process. So that's why in our case here, you see, when you say numerical, possible numerical outcomes. So it's not just 2, 5, 10, and 20. So all these are the chance. So numerical, that means it's a number. So we let X represent the price value. So when you talk about chance, the total of chance. Chance means you say probability. Means you're talking about probabilities must be equal to 1. You are talking about the whole situation. So the whole situation to happen, the chances is 1. That means it's 100%. So there is another outcome for this variable X here. That is you didn't get anything. So the chance is 0.5. Are you clear? So that is called a random variable. It must be a numerical outcome of a chance process. Change. Are you clear? So when you talk about chance, you talk about likelihood. Likelihood means probability. So remember, if we talk about likelihood, if it is more than 50%, we say it's likely to happen. If less than 50%, that is called unlikely. If you talk about 50%, you will say equal chance. So that is how you translate the value of the probability into words. Clear? So now you know what is a random variable. It must be a numerical outcomes. So there are situations whereby it is not a numerical outcomes. So later we will talk about it. We will try to use number to represent it. So it becomes a numerical outcomes. Clear? So that will be in the later part of the chapter. So everyone, do you know what is a random variable? Okay, then what is a discrete variable, random variable? Okay, who can answer me now? Based on your understanding of what is a random variable, now can you please tell me what is a discrete random variable?
The discrete one has a set of distinct possible values.
Yes.
So
What do you mean by discrete? What do you mean by discrete? You have to explain the word discrete.
countable.
Yes, thank you. So when you say a discrete random variable, we will say it is a random variable. Definitely. Random variable that can take on a countable or listable sets of outcomes. So is this a discrete random variable? And each outcome has a probability associated with it. And all the probabilities add up to 1. So just now I told you already, this is you have to come out by yourself. So don't just think that whatever the question gives is the complete one. You have to read the question and see how it happened. Okay. Clear? Any, so clear? So we have another type of random variable. We call it a continuous random variable. We will learn it in chapter 8. Okay? Any question? Can I move on? Okay, now. Third question. What is a probability distribution? When you distribute, correct? You distribute the probability, am I right? So what is a probability distribution? It's a distribution of probability. We are not going to say it like that. This is a probability distribution. So how are you going to put it in words? This is one form of it. Hello, anyone want to try? So in statistic, definition is very, very important. Huh?
It is a display of probabilities corresponding to each random variable.
Yeah, it is a display, correct. You are not, correct. So it is a display, okay? So you can Google, correct? Okay, so I will write it as, is any representation. Okay, you can use the word display. Is any representation of the possible outcome. So when we talk about statistic, when we talk about probability, we always have the word possible outcomes of a random variable it's just the random variable and their what? Associated probability is any representation. So it can be in the form of, so this is called the representation or the display in the form of a table. So for our case here, it's in the form of a table, okay? Or graph. When you say graph, it can be a bar chart. It can be it can be a bar chart, pie chart. Okay. Okay. Or it can be a curve. Okay, in the form of graph, or in chapter 8, we will talk about in the form of a function. Are you clear? So this is called probability distribution. It is, you put it in the form of a table or graph. When you talk about graph, it can be a pie chart, it can be a bar chart, it can be a line graph, or it can be just a curve. Or you can put it in the form of a function that shows the relationship between what? The random variable and its probability. So the random variable is the independent variable and the probability is the dependent variable. So probability always we put on the vertical axis or we put it the second line of the table. You must have this first, then only you have this. Are you clear? Okay. So I hope I give you a full understanding of what do you mean by probability distribution. Yeah. It can be in the form of a table. It can be in the form of a graph. It can be in the form of a function that we will learn in chapter 8. Okay, so now, next one. Next question. What can we do with the probability distribution? After you got your representation already, first you got a problem. Yeah, you recognize your random variable. You know the difference between discrete random variable and continuous variable. Now you build your probability distribution. So this is called probability distribution table. This is in the form of a table. So we call this a probability distribution table. So after you have presented, so it becomes a very clear cut. So what can I do with this? Can someone give me some idea?
Can obtain estimates of the probability that a certain event may occur or estimate the variability
I don't have
of...
to estimate.
Oh,
I can straight away. Probability of getting no price is 50%. So what can you do with this?
can predict the outcome. No, wait.
Okay, what do you mean by predict the outcome?
Predict the probability of the most likely probability of the most probable outcome.
Yeah, the most probable outcome I can just read from here. So the highest chances of you to not, okay, the mode will be getting nothing. Hello,
Yes.
student? We learn in chapter 6. What can you do with this probability distribution? We can do a few of discussion. We can make conclusion. So what can we discuss if we look at here? Or what can we count? Hello? Okay. Okay. So we can make conclusion about the situation. So one of your friends said you can count, you can predict the expected outcome. That is, in here we will write as EX. So how to predict this, you tell me? How to predict this?
Counting the mean
Huh?
by getting the mean.
Yes. You can get the mean. You can count the mean. So I told you already, mean means expected outcome. So if I go and play this game, what is the expected? What is the expected price that what is the price that I expect to gain? Can you please take out your calculator and start to count?
It's the most expected. You
Take
win
out
a,
your calculator and count. Take out your calculator and count. How to count mean? Still remember? The formula to count mean is sum of fx over sum of f, correct? So in this case, it will be sum of pi xi, because we are talking about the probability over sum of pi. So this one will become sum of pi xi. Why I can write it like that? And do you know how to use your calculator and count? Christopher, can you direct Miss Do how to use calculator and count the mean for this case?
You put instead.
Okay. You tell me lah. I follow your instruction.
Yeah, I still keying in.
Yeah. I put in stack lah. So you have to tell me put in stack. Go to edit. Okay. You key in. Key in L1 as 0. Zero. So you go to stack. Everyone should know. Edit. L1 is your X. L2 is your probability. Okay, 0, 1, 0, 2, 5, 10, 20. And 0 0.5, 0 0.35, 0 0.1, 0 0.04, and 0 0.01. Okay. So can I have the answer, Christopher?
1.8.
1.8. Is that correct? So that means every time when I go and play this game, I will expect to get back 1.8. Hello? So that means what can you do with the probability distribution table? Distribution. Okay. So student, can you have a look at this? From here to here. Why I can write is equal to sum of pi xi. Can someone explain to me?
The sum of pi is always 1.
Yes, thank you. Because sum of probability. Remember, remember this fact. Sum of probability is always equal to 1. So this is a very important fact. And why I write it as population mean? And if you look at your calculator, the spread also you get as a population mean, correct? Population standard deviation, correct? May I know what is the population standard deviation for this case? Christopher, since you have counted it, you scroll down.
2.94.
Okay, so that is the spread of the data. Okay, so now, can someone tell me why is this a population mean and population standard deviation? Okay. If you can't, then I will let you know. When you talk about probability, when you have this word probability, correct? It means also proportion. Can you tell me what is the meaning of proportion? When you learn proportion, that means you learn about fraction. But in this case, whenever we talk about proportion, correct, we must put in percentage, huh? So what do you mean by proportion? What do you mean by percentage? What do you mean by fraction?
A part, share, or number considered to in comparative relation to a whole.
Yes. So just make it simple. Proportion means what? Part of?
A whole.
Yes. The whole means the population. So that's why this is population mean. So you see, when you talk about statistics, you have to know all this. So at the bottom line, why do we need to build probability distribution? So that we not only can count the mean, we can do a lot of things with it. So what can we do with it? Huh? We can discuss the shape of the distribution. So when we talk about the shape, still remember, how are we going to discuss the distribution? For this discrete random variable, you can plot a bar chart or a spike diagram, am I right? Do you know what is a spike diagram? A spike diagram means like that. Here is the probability, and here is the variable x. So when you talk about 0, you draw. So one line. You talk about 2, the probability is 0.35. When you talk about 5, the probability is 0.1. So when you talk about 10, so this is called a spike diagram. So it's very low here. You can use your calculator to draw the spike diagram. So this is called spike. Spike diagram. Okay. So from the graph, from the shape of the graph, so we can talk about the shape is what? Skew. This is skew what? Skew right. That is positively skewed. Or there are another option for this case. So you can talk about the shape. So the shape can be skew left. Still remember? Skew left, it will go like that. This is called skew left, correct? Or it can be symmetrical. Which is like that. Okay, now if I give you an example of a distribution. Do you consider this as symmetrical? Is this symmetrical? Someone please? Is spike diagram asymmetrical? Is spike diagram asymmetrical? Okay, I will wait for your answer.
No,
Why?
because the values are randomly spiking.
This one also randomly spiking one.
Wait, which one?
This one also randomly spiking one.
No.
Why this is symmetrical and this is not? Why B is symmetrical and A is not symmetrical?
B, you can see it clearly increasing and then up to a point and then decreasing. With A, it suddenly increases and decreases without warning or any
Okay.
pattern.
Okay, Johan, if we talk about statistics, right, you explain like that to me, correct? You won't get any marks. I want my student to tell me why this is symmetrical and that is not. Why A is not symmetrical and B is symmetrical. You have to know how to use the word symmetrical to explain. What do you mean by symmetrical in maths? Hello, this is especially for those who want to get A+, you better try. Because I don't know in the exam what type of question they will come up. There is no model answer for any statistic question, I'm telling you. Can you please let me know? Speak it out, please. Okay. Your friend say the left-hand side is the mirror image of the right-hand side along the mode. This is the mode. This is also the mode. Am I right? So do you understand the meaning of symmetrical? The left-hand side is the mirror image of the right-hand side. For this one, non-symmetrical because the left-hand side is not the mirror image of the right-hand side along the mode. So symmetrical is called mirror image. So the mode is a line of symmetry. Are you clear? Okay, so we can discuss the shape. So what else can we do? What else can we do with the distribution? We can what? Discuss the center measure. Center of measure. What are the three center of measure? May I know?
Mean, median, mode.
Yes, mean, median, and mode. Correct? Then we also can discuss about the spread. Spread means what? Spread means what? How do you know the spread? What do you count?
Standard deviation.
So this is the formula to find the standard deviation, the spread of the data. So after that, we also can make conclusion about the population of interest. That means something that is you are interested in. So these are the things that we can do with probability distribution. Okay, so in this case, what is the opening problem interest? What do you want to conclude? If you look at part D, okay, part C is talking about the mean. Part D is talking about what is a fair price for playing this game. So that is what whereby you want to make conclusion. Fair price. So how do you justify fair? I pay how much, I should get back how much, correct? That is called fair. So can you suggest to me? So this is what we do for part 4. We counted the expected outcome as $1.8. That means any player that go and play, he or she is expected to get back 1.80. So what is a fair price for playing this game? So these are you are making conclusion. Is, can someone give me the fair price? Zafan, since you on your mic. Zafan,
Yes.
tell me what is the fair price
Um,
for playing this game? Zafan, I as a player, when I go and play this game, I expected to get back 1.8. So how much must the store owner charge me? So that is fair. Sebastian? Sebastian, are you here? Okay, Sebastian said 2. Look, if you pay the charge me 2, correct? I pay 2. Get back 1.8. I lost 0.2. Is it fair? Is it fair, Sebastian? Is it fair to the player? Is it fair? Is this fair? Is this called fair? Definitely not. Every time I go and play the game, I know already I will lose 20 cents. So do you think I want to play the game? Yes. You shouldn't charge like that. You should charge exactly what you expected. Then some player may get more, some player may get less. That is called luck. What you so call? So now you know why we need to count mean, so that you can tell the game owner or insurance company, you charge me a fair price. So that is how the way statistics work. Are y'all okay? So today's lesson is very important. If you understand today's lesson, then everything there actually is done. I have done until 60. So you better practice. You better go through your 7A. Tomorrow I will discuss all the questions in 7A. If any question you don't understand, okay, then 7A and 7B. Okay. So that is how we are going to teach statistics. You have to understand every term, why you calculate that, why you do that, what is the purpose of doing that. So this 4 questions is the starting of why we learn statistics. Clear? Okay. So I will see you tomorrow with question from exercise 7A and 7B. Thank you, class.
You miss.
Thank you, miss.
Thank you.
Thank you.